Chapter 2.6, Related Rates, Day 2. All right, yesterday we started some related rates. Today we're going to continue working on those. You already have all the steps. You just need more practice. So we're going to go through some more problems. The tricky thing about related rates is it's just a lot of concept application. That seems to be difficult for some people. So we're going to start with a non-application problem. They just give us all the information. We do our plug and chug. All right, so if y squared plus x cubed equals 5, dx dt equals 8, and xy equals 1, 2, find dy dt. They took care of drawing the picture, finding the equation, listing what we know and we don't know. We just need to plug and chug to find dy dt. We'll start by taking our equation and taking the derivative of it. The derivative of y squared with respect to t is 2y dy dt plus derivative of x cubed with respect to t is 3x squared dx dt. And 5 is a constant which never changes, so that's 0. Plug in what we know. We know that y is 2, so 2y becomes 4 dy dt. Plus x is 1, so 3x squared becomes 3. dx dt is 8. So we got 4 dy dt plus 3 times 8 is 0. We'll subtract 3 times 8. 4 dy dt equals negative 24. So the rate of change of y with respect to time is negative 6. All right? That's what it looks like without the story problem attached. You take your equation, you take the derivative, and then it's plug and chug. Right? The hard part is finding the equation in what you know and what you don't know. All right? So we'll take an AP test problem from a couple years ago. I've highlighted the problems we can do now. All right? This is, a container has the shape of an open right circular cone as shown in the figure above. The height of the container is 10 centimeters and the diameter of the opening is 10 centimeters. Water in the container is evaporating so that its depth h is changing at the constant rate, negative 3/10 centimeters per hour. Notice they give us equations, so we don't need to know the volume of a cone. All right? So find the volume of water in the container when h equals 5 centimeters, indicate units of measure. B, find the rate of change of the volume of the water in the container with respect to time when h equals 5, indicate units of measure. We'll start with A. Okay? Find the volume of the water in the container when h equals 5. All right? So when h equals 5, keep in mind our h-r relationship. It's a 1-to-1 relationship. When h is 10, r is 10. So if h is 5, r is 5. Oh, check that. When h is 10, r is 5. So when h is 5, r is 2.5. I was making a mistake here of doing diameter. When h is 10, height is 10, diameter is 10, so radius is 5. So radius is half of height. All right? Now what we could do is we could take this ratio and plug that right into there so we don't have so many variables. In fact, that's what I'm going to recommend us doing. Except I think h equals 2r is easier to do. So I'm going to plug h equals 2r in. So volume equals 1/3 pi r squared times 2r. If we simplify that, we get 2/3 pi r cubed. H equals 5, so r equals 2.5. So that's 2/3 pi times 2.5 cubed, and since it's volume, cubic centimeters. All right? And it doesn't say to round anything, so we can leave it like that. All right? So let's take that. Remember our equation for volume in this was 2 thirds pi r cubed. And if we go back and look, oops, wrong way. H is 2r. All right, find the rate of change of volume. So we're looking for rate of change of volume. That's the change in volume with respect to time, dv dt, when h equals 5. Indicate units of measure. Now I think they told us, yep, depth is changing at a constant rate of -0.3 centimeters per hour. So that's dh dt. dH dt equals -0.3 centimeters per hour. All right. So we want to find dV dt. So take our volume, 2/3 pi r cubed. And let's take the derivative with respect to time. Derivative of velocity with respect to time is dV dt. Power rule, 2 times 2/3 is 2 pi r squared. Since it's not with respect to r, we need a dr dt. And now we'll plug in what we know and we don't know. We know that h equals 5. If h equals 5, r equals 2.5. If h equals 5, dr dt, well, dr dh dt, let's take this equation right here, h equals 2r, and derive that. dh dt equals 2 times dr dt. Well, dh dt is -3/10. So -3/10 equals 2 times dr dt. We'll divide both sides by 2 and we'll see that dr dt is -3/20. So the rate of change of volume with respect to time. Find everything, plug it in. If you want to simplify that, you can. If you don't want to, you can leave it like that. And that would be cubic centimeters per minute. A lot of you are just itching to calculate that out, so we'll do that. 2 pi times 2.5 squared times -3/20 is -5.89 cubic centimeters per hour. Sorry, per hour. Okay. And we're going to stop there. We'll do another problem in class tomorrow, and we'll have another problem on the video tomorrow night. Take some time. If you have questions on this, please ask in class tomorrow. Remember, the steps for a related rate problem are to 1, draw a picture and list what you know and what you don't know. For this problem, they gave us the picture right here and listed a little bit of what they knew. We had to figure out the rest. And what we didn't know, they gave us the equation, we just needed to derive it. All right?